When a laboratory faces an unconventional task and production requirements exceed the capabilities of standard equipment, classic metallographic microscopes are no longer sufficient. In such cases, a microscope without rigid structural limitations is needed. How can you examine the inner surface at the bottom of a cylinder or the top of a tall, thin object? Neither an inverted nor a classic upright microscope can handle such a task. Good afternoon, I am Marina Lobach, the Scientific Director of the MAGUS project. Today, I will introduce you to a series of upright metallographic microscopes that can work with unconventional objects, the MAGUS Metal 630. This microscope features a unique stand, an engineering solution that removes the usual limitations. Object height, complex part shapes, limited workspace, none of these are a problem for the MAGUS Metal 630. The compact stand and original focusing mechanism are specifically designed to work with large and unconventional samples, while the modular design allows the microscope to be integrated into a custom mount or built directly into a production line. This instrument is made for metallurgists, engineers, and researchers. It enables control of the microstructure of metals and alloys, analysis of semiconductors, and inspection of paint and varnish coatings. The MAGUS Metal 630 performs confidently in metallurgy, mechanical engineering, the nuclear and aerospace industries, as well as in university laboratories. Today, we will not go into detail about metal structure and sample preparation. We will study the design of the Metal 630 microscope, the one that opens up new possibilities compared to other models. We will briefly cover the available research methods and review the package contents. Optical system. The objects studied with a metallographic microscope are opaque, so the device operates in reflected light. Light from the lamp passes through a system of lenses, is reflected by a mirror, and directed onto the sample through the objective, then returns back into the objective. The objective forms a magnified image and directs it to the eyepiece or to the camera. In a standard metallographic microscope, the objectives are located above the stage. The surface being examined must be perpendicular to the optical axis. Now, about the sample size. The height of the object being examined is determined by the focusing range. Pay attention to the universal stand of this model. The optical and illumination parts of the microscope are entirely raised along the stand. Next, the focusing mechanism comes into play. This is not just a design feature, but the key to working with objects of different heights. For this model, the comfortable sample height is up to 130 millimeters. However, you can mount the microscope on your own stand, thereby removing the height limitation, or you can integrate the system directly into a production line. Anyone using the microscope in its standard configuration will appreciate the convenience of working with the two-coordinate stage. Let me remind you, to analyze the microstructure of metal alloys, the surface must undergo sample preparation, grinding, polishing, and etching. If the object is, for example, a laser diode and you are assessing the quality of assembly rather than the microstructure, you can examine it in its original state. Let's look at an interesting example. A cylinder. The bottom can be examined from the outside using an inverted microscope. But how do you look at the bottom inside the cylinder? The Metal 630 can easily handle this as well. Of course, there are depth limitations here. The depth of the cylinder is limited by the parfocal height of the objectives, 45 millimeters. The Metal 630 series is also perfectly suited for examining standard samples. Research methods. 4 main methods are available for MAGUS metallographic microscopes: bright field, dark field, polarization, and differential interference contrast, or DIC. Bright field shows a real magnified image of the object. Polarization increases contrast and reveals anisotropic non-metallic inclusions. Dark field highlights scratches and grain boundaries, making them appear bright against a dark background. DIC visualizes micro-relief, converting height differences into light shadow and color contrast. The choice of method depends on the properties of the material and the research objectives. A metallographer usually selects the method empirically, comparing images obtained in different modes. Series modifications. You can choose exactly the configuration your laboratory needs. All models in the series support bright field and polarization. Models with the letters BD in their name additionally support the dark field method. The letters BD stand for bright plus dark. Models with the letters DIC in their name additionally support the DIC method. These models are available by special order. Configuration. The standard configuration includes a base with a stand, focusing mechanism, reflected light illuminator with power supply, trinocular head with eyepieces, revolving nosepiece with objectives, stage, as well as modules for additional research methods. The compact weighted base ensures the stability of the construction. A 2-coordinate stage with clamps and coaxial control knobs is mounted on the base. Thanks to the streamlined stand, the microscope fits on shelves with a height starting from 40 centimeters. The optical unit with the illuminator moves along the stand. The focusing mechanism is coaxial. The fine focus division value is 2 microns. The stiffness of the coarse focus movement is adjusted by a ring on the left side. The revolving nosepiece is designed for 5 objectives. The empty slot is used for centering the lamp or installing an additional objective. The objectives are planar chromats with an extended working distance. The parfocal height is 45 mm and the linear field of view is 22 mm. The objective housing displays the following parameters: PLL, type of correction, planar chromat, long focus, magnification, numerical aperture, tube length, infinity, BD or Dixie method. The color coding corresponds to the magnification according to international standards. The microscopes are equipped with objectives of 5, 10, 20, and 50 times magnification. Additionally, objectives with 40, 60, 80, and 100 times magnification are available. Please note, microscopes operating in dark field mode are equipped with special objectives. Objectives marked BD have an annular gap between the optics and the housing. The mounting diameter and thread of these objectives differ from models designed only for bright field. Therefore, when choosing additional objectives, it is important to consider compatibility. Illumination system. The illuminator allows you to adjust the lighting using the Köhler method. The light source is located in the lamp housing and the lamp is centered along 3 axes. Power is supplied through a separate unit. The field and aperture diaphragms are factory centered, but if necessary, the position of the field diaphragm can be adjusted. To observe objects in polarized light, a polarizer and analyzer are introduced into the optical path. The polarizer rotates 360 degrees, providing precise adjustment of polarization and contrast. By rotating the polarizer, the required position of the polarization devices is set, and then the brightness of the illumination is adjusted. Light filters are used to optimize image contrast for different types of specimens. The MAGUS Metal 630BD model is equipped with a built-in dark field unit. Switching between bright field and dark field is done using the handle on the illuminator. When the handle is pulled out, the illumination passes through the objective lenses and the microscope operates in bright field mode. When the handle is pushed in, oblique illumination is activated and the microscope operates in dark field mode. Objectives marked with BD support both methods: visual head and eyepieces. The visual head is trinocular. The interpupillary distance can be adjusted from 48 to 75 millimeters. The distance value is read off the scale. The inclination angle is 30 degrees. The standard package includes 10 times eyepieces with a field of view of 22 millimeters, featuring long eye relief for comfortable use both with and without glasses. Removable eye cups protect against stray light. The eyepiece mounting diameter is 30 millimeters. A diopter adjustment ring is located on the left tube. Additionally, 10 times eyepieces with a scale are available, as well as eyepieces with magnifications of 12.5, 15, 16, 20, and 25 times. Digital visualization. A digital camera with software for image analysis and measurements is purchased separately. The camera is installed in the vertical tube via a C-mount adapter. The single magnification adapter, which comes as standard, is suitable for sensors about 1 inch in size. For smaller sensors, we recommend 0.5 times or 0.65 times adapters as they increase the field of view. The light path selector directs light either to the eyepieces or to the camera port, which eliminates stray illumination. The software not only allows you to display the image on the screen, but also to take measurements, save data, and stitch images together. So let's sum up. The MAGUS Metal 630 is a series of upright metallographic microscopes designed for studying metal alloys, paint coatings, and electronic components. The main feature is the universal stand. Thanks to its compact design, the microscope fits even on shelves as low as 40 centimeters, and the well-thought-out focusing system removes any limitations on the height of the object being studied. The 2-coordinate stage provides convenience when working with small samples. The microscopes in this series support all classic research methods: bright field, dark field, polarization, and DIC. The differences between the models lie in the set of available methods. Köhler illumination adjustment, plan achromatic objectives, and wide field eyepieces provide high resolution, contrast, and aberration correction. A digital camera and software complement the system with analysis and documentation capabilities. To make sure you're making the right choice, visit the MAGUS demonstration hall. Here, you will receive expert advice, test the microscope with your own samples, and select the optimal configuration for your laboratory's needs. See you soon!